Hello everyone, I hope you have had a wonderful day. I'm back again with another video from LLM 0 to 100 series. If you have watched the YouTube channel, you know that I've uploaded a couple of videos showing you how to use GPT models to design different systems. And in one of the videos, I showed you how to design RAG-GPT, which is a chatbot that gives us the ability to chat with our documents. Either the documents that we processed and created the index earlier, or we could also upload a document, a PDF file, while we are using the user interface. So in this video, I want to show you how to design RAG-GPT, but with open source models. And for the open source large language model, I want to use Google Gemma, which is an open source large language model that Google announced it and released it last week. So I wanted to both test this model, and also I want to use it and show you how you can design a RAG system with open source large language models. So first, let me show you the performance of the two chatbots, and then I will explain how you can design this chatbot step by step. So I've already processed and created an index, and both of the chatbots are connected to that index. And one of the documents that I processed for testing is called How to Start a Startup, and it is coming, I believe, from a speech from Sam Altman. So one question that we can ask from that document is, how do I identify a market has a fast growth rate now and also for the next 10 years? If I ask the same question from both chatbots, on the left we see the performance of GPT, and on the right we see the performance of Gemma. The answer that GPT gave us is, according to the retrieved content, the speaker suggests that one way to identify if a market has a fast growth rate now and for the next 10 years is to trust your instincts and observe what you and your friends are doing. So the answer that Gemma gave us is, trust your instincts, think about what you're doing more, think about what you are using, what you are seeing people your age using, and that will almost certainly be the future. Considering the fact that GPT 3.5 has 175 billion parameters and Gemma only has 7 billion parameters, this is an absolutely amazing performance. So we can actually use open source models and design this RAG chatbot. So RAG aside, I decided to also change a few settings for this chatbot compared to RAG-GPT. So as you can see on the bottom, I included more settings to give us the flexibility to change the performance of our large language model. This chatbot also gives us the reference, the retrieved contents that we used, and we passed them to the large language model, so the large language model can give us the answer. And the other feature that this chatbot gives you is to upload a PDF file or a document and start chatting with it while you're using the user interface. So now let me show you how to design this chatbot step by step. Let's start by the project schema of our chatbot. So this is RAG-GPT. And in that video, I showed you how to design this chatbot in 4 different steps. The first step would be to prepare the vector database from your documents. Second step is the exact same process, and the only difference is we are processing the documents that we upload while we are using the user interface. The third step is chatting with the chatbot, searching our query over the vector database, retrieving the content, preparing the input for the GPT model, which contains the retrieved content, the memory, the user's query, along with the system role in order to get the answer. And finally, there was a fourth step that enabled us to summarize long PDF files. And for this chatbot, I used OpenAI models. For the large language model, I used GPT 3.5, and for the embedding model, I used text embedding ADA 002. I want to take the exact same project that we designed in RAG-GPT with only one small change. I want to remove this last branch, the orange branch, because first of all, this is not RAG, and I just added it on that project because I was curious to see how that works. And the second reason is this process by itself is a very heavy process for a 7 billion parameter model. So it's not going to be an efficient branch for that chatbot. So I will take a replica of RAG-GPT, which also allows me to, instead of focusing on the steps of designing a RAG pipeline, which I've fully covered all the steps from chunking, creating the vector database, vector search, etc. on RAG-GPT, to focus on the other challenges that rise when we use open source models. For this chatbot, for the large language model, I want to use Gemma 7 billion from Google. And for the embedding model, I want to use bge-large, which is one of the best open source embedding models available in Huggingface, and you can use it for free. The big difference between an open source chatbot with a chatbot that is connected, for example, to a model like GPT is when we use a model like GPT, we get an API key and we send our query to OpenAI and we get the response from them. So technically, we don't need to worry about the computational power required for running GPT models. But when we want to design an open source chatbot, that would be problem number one, because we need computational power to run these large language models. For a 7 billion parameter model, you need at least a GPU with 8 gigabytes of VRAM. And for that, you have to load the quantized version of a 7 billion parameter model. If you just load it as it is without applying quantization, you wouldn't be able to fit a 7 billion parameter model even on a GPU with 8 gigabytes of RAM. That is problem number one. And the second problem is loading the large language model, because loading it by itself is also a heavy process. You have to be careful, and you shouldn't put the loading process of the large language model directly into the body of the chatbot. Well, the problem with that is the inference time is going to take a long time every time, because you have to load the large language model with each query. And beside that, when you're loading a 7 billion parameter model on your GPU, if you want to load that model over and over again, actually after the first few times, there is a great chance that your computer, your GPU is going to get overwhelmed, because when the second model is going to be loaded, the first model is not going to be completely cached out from your GPU, and your GPU will not be able to handle multiple loadings over time. So how can we solve those problems? The answer is simple. We can design a web server on which we load our large language model and keep it waiting for our user's query. So the exact same thing that we had between our chatbot and OpenAI, but instead of sending our queries through the API call to OpenAI and get the response, we are going to send our queries to our large language model, which is waiting, and get the response in return and show it to our user. And I also want to show you how to use Postman in order to test whatever we have on the server side without the need for having an actual user sending a query to it. Because when you develop these type of systems, you need a way to test them separately and to develop them separately. Before I show you the code, I just want to mention one more thing which is going to help you a lot with designing your RAG chatbots, and that is how you should think about the context length of a large language model. So in case you use a large language model, you have to keep it in mind that if it has a 10K token limit, you shouldn't think about using the whole capacity of that large language model. So this is a paper called Lost in the Middle, which is a very wonderful paper. And they experimented this aspect and found a very interesting result. So let me read this one sentence for you. Performance is highest when relevant information occurs at the very start or end of the context. So when you want to design a RAG system, you want to pass to the large language model the retrieved content. So be careful about the number of chunks and the size of the content that you want to retrieve and pass it to the large language model actually. So you might want to retrieve a huge amount of content, but you definitely want to start, for example, applying re-ranking or some other techniques to reduce it a little bit and then pass that to the large language model. Because let's say if your large language model has 16K of the context length and you pass over 15K of token to that large language model, most definitely that large language model is going to get overwhelmed and is not going to perform as you expect. So yeah, just keep it in mind. This is one thing that I wanted to also mention in this video, and let's jump on the code. Let me first explain the project structure, which is the exact same structure that I have been using since the beginning of this series. So I have the config folder, which contains the YAML file that includes all the configs that we want to use in our project. I have the data folder, which contains our documents. These are the 3 documents that I've already pre-processed and created the index from. So I use these 3 documents in the demo in the beginning of the video. And we also have 2 documents here, which I will use while we are chatting with the chatbot to upload them and chat with them on the fly. It has a notebooks folder, and I want to show you how to load Gemma because you have to go through a few steps. But with regard to the main project, you see that I have LLM-serve.py, which is an empty module right now, and we are going to write the code together. And in the utils folder, if you go in prepare vector database, which was the module that I used to create the vector database, both for vector databases that we created before using the chatbot and also for creating the vector database from the documents that we could upload while using the chatbot. One difference that you can notice here is the embedding function. Here I'm using Huggingface embeddings and I'm loading bge-large-en embedding model. Now I want to quickly show you how you can load Gemma and interact with it. So I have added the link to the Huggingface page for Gemma, and if you check the page, you're going to see a lot of information. Feel free to check them out. But they provided us with one way to load the model and the tokenizer. Feel free to use this one. But in my code, I personally load the model separately. I don't load it from the pipeline itself. And after loading both the tokenizer and the model, I create the pipeline from them. So there is one step that I mentioned that you have to take, which is you must be authenticated in order to load Gemma. And for that, you need to have a Huggingface profile. And from your profile setting, you can generate a new token. As soon as you have the new token, you can create an argument. And then when you want to, for example, load the tokenizer, you can just pass the token here. And when you want to load the model, you can pass the token here. So as soon as I load the tokenizer and I load the model, I wrap them up in a pipeline, and then we can start interacting with the model. So for example, the first message is hello, and the model gave us hello. It is nice to hear from you. What would you like to talk about today? Let's say something, for example, tell me a joke. Why did the tomato turn red? Because it saw the salad dressing. So yes, you can start interacting with the model, and just keep it in mind that you need a token for that. So now let me show you how to create that web service and load the model on it. Let me also close this notebook. Okay. So this is the module that I want to use for it. Of course, the first step would be to import some libraries. So I want Torch. That is the first library that we need. And from Flask, I want to import Flask itself. And beside Flask, I also want request, and I also want JSONify. Then from transformers, I want to import auto tokenizer, and I also want to import auto model for causal LLM, and I also want to import the pipeline. So these are the classes that we need from transformers. Of course, we also need to load our config. So from utils.loadConfig, import loadConfig. I will create an instance called appcfg or appconfig from our loadConfig. So like this, I just imported all the configs into our module, and then I can start using it in order to, let's say, distribute the configs throughout the code. So to start a Flask app, the first step that we need to do is Flask itself. So this is a step number 1. In the next step, I want to start loading my model. So again, as I said, I would just also copy paste the code here because this is not part of what we want to develop. It is just something that we can copy paste and use it. So here I'm loading my tokenizer, I'm loading my model, and I'm also creating the pipeline. So in the next step, we want to create a function which is going to listen to our queries that are going to be sent to it. So for that, I want to create an app.route for our Flask, and I will call the function generate text, and for the method I will give it the post method. So like this, if I now start defining a function with the name generate text, and if I pass, for example, a specific port to my Flask app, that port, and as soon as I run this module, that port is going to listen to whatever we are going to send to it. And if we point our queries to this function, to this generate text, it is going to take it and process it for us. So now let's continue. So this function is not going to take any argument. I will just send it a JSON input data. So our data is going to be in a JSON format. So that is how I can extract my data from the message that this function is going to receive. Then from that data, I'm going to import my prompt, which is data.get, and then I have my prompt. So this is how I extract the user's prompt. And in the next step, I want to start defining some of the configs for the large language model itself. So these configs are going to be part of the input data that this function is going to receive as well. But there are specifically 5 different configs here: max new tokens, do sample, temperature, top K, and top P. In general, by using these configs, for instance, with this one, you're going to set the number of tokens that the model is going to use for generating the output. You set the temperature, so you define how much your model should be creative for generating the output, which usually in the RAG systems, I put it as the minimum value. And in case of Gemma, the minimum value is 0.1. And top K and top P, these are some variables that can again affect the performance of the model and somehow make the model to be more restrictive about the response that it's going to give us, or let's say be more flexible about it. So these are also some of the inputs that it's going to receive. And then in the next step, we want to tokenize our prompt and pass it to the large language model for inferencing. So if you check the notebook, this is the exact part that we need for this step. So let me call it tokenized prompt. And I also change it to this one so I can pass the prompt to it. I also need to change the name of this pipeline just to avoid confusion for Python. And the next step is replacing all these variables with what we just received from the user side. So I have max token, I have do sample, temperature, top K, and top P. Okay, just like that, we are getting the user's message. We are extracting all the necessary information that we need to pass to the large language model. We are tokenizing the prompt. We are passing everything to the large language model, and we are getting the output from it. In order to send it back to the user again, I want to use the JSON format. So I will return. I will use JSONify, and I have a dictionary which has a response as the key. And on the other side, I have as a value, I have exactly this value. So if you pay attention, you will see that I'm removing the length of the prompt from the output. And that is because when Gemma generates an output, it also includes the user's query in it. So this is one way to just clean your output. Let's just pass this to our user. So right now I have this app ready. And if I just simply turn it into an executable module by, okay, so if name main app.run. So I want to give it a specific port. just to make sure that I can also pass the same port to my app. So I will pass it port number 8888, and I also want to set debug equal to false, and that is because if we set it to true every time that you want to fix something actually and change something, it is going to execute the whole module again. And that means it is going to load the model again and again, and that means it is going to overwhelm the GPU. So you need to be a little bit careful about how you want to develop this module and how you want to interact with it. So right now we have the web server ready. And if we can somehow send the input that it expects, we can test if it works without any issue or not. So let me first quickly test the code python source llmserve.py and make sure that everything is okay. So I will also open my Postman, and here we go. So it is loading the model and we have an error. Got an unexpected argument method. This should be methods. Okay, so let's try it again. So the model was loaded and we can send our queries to it. So this is Postman, and I've already passed the URL and I chose post. This is what I'm going to do. And if you check the headers, you can set a content type, and in the body, we have to define the exact input that our app here expects. So here, as you can see, I have the prompt, and here I have a key called prompt. And in the prompt, I have this format. So if you check the notebook, you can see that this is the exact format that Gemma expects. So I'm going to use the same format. And then we have the max new tokens, which we are extracting here, and the rest of the model config. So if I push send, I will get an error. So this error says pipeline. Yeah, that is correct, because I don't have the pipeline name, so I have to just quickly run the app again. So let me test again. If I send the request right now, so it got the request and it is processing it. Okay, so I said tell me a story about a bee, and this is the model's response. So it actually gave me a story about a bee. So if I also simply say hello to our model right now and push send, it came back with hello, it's a pleasure to hear from you. So as you can see, you can start testing your web server using Postman, and this is just a very easy way without the need for having all the chatbot and everything on the other side to just test and make sure that what you developed right here is working without any issue. The next step is to modify RAG-GPT, and in the chatbot, if you remember, when I was using OpenAI model, I was just simply getting the user's query, passing it to the GPT chat completion function, and I was getting the OpenAI response. Right now, I'm going through the whole process, and I create the message from the user's input, and I also wrap the message along with the system role. And right now I'm not using a chat history, unlike when we were using GPT, because this model is just not as big as GPT model, so it's going to get confused. So right now I just have the system role, the user's query, and the retrieved contents from the vector search. And I create the exact same data that we just saw right here in the body, and this is the exact same structure that our model expects. And I send it through request.post to our Flask app endpoint, and our Flask app endpoint is the exact local host that we just ran the app on it. So this is port 8888, and this is generate text function. So that's it. If I now send this request, in the output, which is the response, I should be able to get the model's response, and then I just simply convert it to JSON just to make sure, and I send it to the user. So now let's test our user interface. So if I have Python source and app. Okay, so it's running. If I say hello, probably hello is going to get the model confused because I strictly told it to provide an answer based on the retrieved content. Sure, here is a response to the prompt. Let's start asking questions, because actually when you start asking questions from the model, it has a much better performance. So in the demo of the video, I showed you this question. Let's ask it again. We saw that this model was able to give us a reasonable answer. And actually, if we open the PDF file, you will see that it is pointing to the right PDF. This is the question that I'm asking right now. Let's also ask another question. How do you deal with burnout while still being productive? You just keep going. You rely on people. It is really important. Let's double check the result. So here we have keep going. Yeah, so the model was actually able to get the concept behind that question. So as you can see, Gemma is not perfect, but it is good enough for you to understand how an open source RAG chatbot works. So now let's also test the upload PDF and see how that works. First, we need to change this to upload doc process for RAG. And then you can select as many PDF files as you want. So right now I just want to pass one PDF. And as you can see, it goes through the process of preparing the vector database. And as soon as it is ready, it says uploaded files are ready. Please ask your question. So in that PDF, I have 3 stories about 3 fictional characters. And there is no way if a large language model can answer correctly if I just simply ask who is Fred. So let's see. What does it say? Fred is a small red fish who lived in a cozy coral reef in a vast shimmering ocean. So let's go to the PDF. This is the PDF, and this is Fred the red fish. So that was the correct answer. The model was able to correctly understand who is this character named Fred and give us the answer. So I just want to mention 2 more things before wrapping the video up. I want to show you how much GPU this model is utilizing right now. So as you can see, I have 24 gigabytes of VRAM on my GPU, and from that 21.7 gigabyte is already occupied. So if you don't load the quantized version of the model, and with this system, this is the GPU usage that you're going to have. The second point is, it probably crossed your mind that if I created a web server for my large language model, why didn't I do the same for the embedding model? We are also loading an open source embedding model. The simple answer is you definitely have to do it if you want to deploy your RAG system into production somewhere, and to have a server and load your embedding model somewhere, and you also have a server and load your large language model somewhere. But in this code, I didn't do it, first for simplicity, and the second reason that I didn't do it is, compared to the large language model, loading the embedding model is much faster, and to some extent it wouldn't have affected the performance that much. And on the other side, I did one important step, which is if you check chatbot module, and this is where I'm going to load the embedding every time that the user sends a query, right? Because I want to perform a vector search on my index. So before performing the vector search, I created the embedding model and I pass it to my Chroma for creating the vector database instance. So this is the embedding function. So this right here is going to be executed every time that our user is sending a message, which is not an efficient way by itself. However, I added a piece of code at the end of this process, which is deleting the instance of the vector database, deleting all the documents, and emptying the cache of my GPU. So if you don't do it, actually this small model is also going to overwhelm your GPU. So give it a try, and you will see that without removing the vector database that contains your embedding model and without emptying the GPU cache, you most probably will have a problem even with this small model. So definitely, if you are planning to deploy your models into production, first of all, use a bigger large language model, and also make sure that you load your large language model somewhere waiting for your calls, and also you load your embedding model somewhere waiting for your calls. So you have to address these two aspects as well. And right now you have all the tools at your disposal to design your RAG systems with or without open source models and deploy it into production. Thank you very much for watching the video, and I will see you in the next one.